Good evening, GCC. So we're back to the second part of tonight's lesson, which is 12.2, Systems of Linear Equations. This is a new method now, something called solving it with matrices. Now, all the algebra and the other methods that we did, graphing, we've certainly done graphing before. We should be familiar with that. Substitution and elimination, nothing really new there. All the algebra that we were doing is stuff we've done before. You just got to know what to do and when to do it. But when it comes to matrices, this could be something brand new. You might never have even seen a matrix before. Let's spend a moment talking about exactly what is a matrix. A matrix is a rectangular array of numbers. And it's separated with brackets. For example, I could have the following matrix. So I've got a rectangular array. Kind of looks like a data table, doesn't it? Some sort of a table or spreadsheet or something. And that's really what it is, a matrix here. Now notice the numbers, everything kind of in its place. I'm allowed to have fractions or square roots or negative, and if I've got 0, I have to put a 0 in here. So think about this as a spreadsheet. Now, matrices are comprised of rows and columns. These are the rows, and these are the columns. So I've got rows and columns in a matrix. Every entry is called, well, an entry. Matrices are usually named with a capital letter. So, for example, I could call this matrix capital A. And then every entry is based on the rows and columns. So that 4 would be A 1, 2. In matrix A, row 1, column 2. Row 1, column 2. That would be the entry that comprised that matrix there. The main characteristics of matrices are their dimensions. And when we talk about the dimensions of a matrix, we talk about rows and columns. So this particular matrix would be a 2 by 3. 2 rows by 3 columns. And we can add matrices together. They have to have exactly the same dimensions, and then we just add the corresponding entries. Same thing with subtraction. Multiplying is a really weird process, and dividing, there's no really any such thing as dividing with matrices. But what we're going to do is we're going to take our systems of equations and write them in matrix form, and then use some matrix operations. So a couple of steps to tonight's lesson. The first one is going to be just taking a look at a system of equations. For example, something like x minus 3y equals 7, and 4x plus 9y equals 0. And I'm going to rewrite this as a matrix. Rewrite this in a matrix format. So as I put it in a matrix format, the first column is going to be the coefficients of the x, the 1 and the 4. The second column is the coefficients of the y's, the negative 3 and the 9. And then the third column is the constants, the 7 and the 10. Now, these are coefficients of variables. These are constants. So what we're actually going to do is we're going to put a line right down the middle, and this is an augmentation, to differentiate between the variables and the constants. So this is actually something called an augmented matrix. Notice that the rows are the equations. 1x minus 3y equals 7, 4x plus 9y equals 10. The columns are the coefficients of the x's, coefficients of the y's, and the constants. So we can rewrite in matrix form, and we can also go the other way as well. So for example, suppose I had the matrix 4, 2 with an augmentation of 1, negative 5, negative 1 with an augmentation of 6. and I said rewrite this as a system of equations. Well, the first row is the first equation. So there's my coefficient of x's, 4x's. There's my coefficient of y's, plus 2y's. There's my constant, the augmentation equals 1. Negative 5x's, second row, second equation. Negative 1y equals 6. So being able to rewrite between systems of equations and matrix form is kind of the first method, if you will, the first step in this, being able to rewrite these. Now, once we take the system and rewrite it in a matrix form, we have to use what's called matrix row operations. Now, there's only certain things we're allowed to do with matrices when we're working with the different rows. We are allowed to interchange rows. For example, I could make row 1 as row 2 or row 2 as row 1. Really doesn't matter. The next thing we're allowed to do is we can multiply or divide a row by a number, by some sort of constant. That would be the same as if I just took the equation and multiplied everything in the equation by like a 3 or negative 2, just like we did in solving systems. The next thing we can do is we can combine rows. We can add 2 rows together. It would be like adding two matrices together. Same kind of thing as that. All right. Let's take a look at some of these rows, and those are the only things we can do. We can't subtract from a number. We can't do anything else. That's all we're allowed to do. All right. Let's take a look at doing some row operations here. Suppose I had the following matrix. 2, negative 1, 5, 3, 2, and 7. And what I want to do is I'm going to take 2 times row 1, add it to row 2, and put it in for row 2. Now, this line of code here is the row operations code. Row 1 is like the first equation, row 2 is like the second equation. And what I'm going to do is I'm going to take 2 times everything in row 1, and then I'm going to add it to everything in row 2, and then I'm going to put it in for row 2. So if I do this operation, just that operation, what's my new matrix going to look like? Well, row 1 isn't changing. Row 1 is going to stay exactly the same. But I'm going to take 2 times this and add it to that and put it in here. 2 times 2 is 4. 2 times row 1 is 4. Plus 3 is 7. And put it in there. 2 times negative 1 is negative 2. Plus 2, right? 2 times what's in row 1. 2 times negative 1 is negative 2. Plus what's in row 2. Plus 2 is 0. And put that in for row 2. 0. 2 times row 1. 2 times 5 is 10. Plus row 2, 7. 10 plus 7 is 17. Now, when we do these row operations, we're only ever changing one row at a time. Okay? Let me give you one to try here. Let me give you another matrix. Suppose I have the following matrix: 4, 0, 3, negative 2, 5, 1, 1, 7, and 2, 8, 2, negative 2. And here's the row operation that I want you to perform. I want you to do 2 times row 2, add it to row 1, and put it in place of row 1. So do 2 times what's in row 2, add that to what's in row 1, and put it in for where row 1 was. Now remember, we only ever change one row at a time. So every time I do something, I'm only going to change row 1. So these two are going to stay the same. 5, 1, 1, 7, and 2, 8, 2, negative 2. They stay the same. We only ever change one row at a time. Now, how am I changing this one? 2 times row 2, 2 times row 2, and add it to row 1. 2 times 5 is 10, plus 4 is 14 is the new entry in row 1. Row 1, column 1. 2 times 1 is 2, plus 0 is 2. 2 times 1 is 2, plus 3 is 5. 2 times 7 is 14, and negative 2 is 12. All right, one more, and then we'll see why we're doing this and where this is going. So in this next one, I've got 2, negative 1, 3, and I've got 6, 5, negative 5. Now this is the following row operation that I want to do. I want to do negative 3 times row 1, and I want to add that to row 2 and put it in for row 2. So I'm saying it in English and I'm writing it in math. Negative 3 times what's in row 1, add that to what's in row 2 and put it in for row 2. Remember, every time we do one of these things, we're only changing one row at a time. I'm only changing row 2. Row 1 is going to stay the same. 2, negative 1, and 3. All right, here we go. Negative 3 times row 1, which is negative 6, plus row 2, which is 6, 0. Negative 3 times negative 1 is positive 3, plus 5 is 8. And then negative 3 times 3 is negative 9, plus negative 5 is negative 14. All right, now why are we doing this? What's the purpose of this? Well, this equation, if I rewrite this as an equation, this is saying 2x's minus a y is 3. This one is saying 6x's plus 5y's is negative 5. This one is still saying the same thing. 2x minus y equals 3. But what is this one now saying? No x's and 8y's is negative 14. If I divide both sides by 8, I can solve for y very quickly. So I want to have zeros in here, and then I could just take this whole row, divide by 8, divide by 8, divide by 8, and I know what y equals. I would get no x's and 1y equals 14. That's a special name for that type of matrix. If I have something that looks like this, take a look at this matrix and interpret what is it saying. 1 x's and no y's is negative 3. In other words, x equals negative 3. No x's and 1 y is 4. In other words, y equals 4. When it looks like this, we have our solution. All right, so now putting it all together, where we're going to go from a system of equations, we're going to write it as an augmented matrix, and then use row operations to solve it. So we're going to put all of this together now. So here is my system of equations. X minus 2y's is 2, and 3x's minus 5y's is 9. There's my system. Now, if I had to solve this any old method that I'd like, I think I would multiply the first equation by a negative 3, because then the x's would get eliminated. Or add 2y's to both sides, and I would get x equals 2y plus 2, and I could plug that in there and solve for y's. So I could use this any method. I don't think I would want to solve this one graphically. If I subtracted x and divide by negative 2, I'm going to have fractions everywhere. Subtract 3x's, divide by negative 5, horrible fractions everywhere. I wouldn't want to graph that at all. The slope would be fractions, the y-intercepts would be fractions. That would be a very awkward system to try to solve. with graphing. But we're going to solve this one by putting it into an augmented matrix. So we're going to put it into an augmented matrix. Remember, I'm only going to use the coefficients, 1, -2. The augmentation is 2. Coefficient of 3, coefficient of -5, augmentation is 9. So now I've got my system as an augmented matrix. Now what I want to do is I want to get it to where I've got zeros and ones in here. I've already got a 1 here, which is nice. But this isn't telling me that x is equal to 2. This is telling me that an x minus 2y's is 2. I'm going to want to get rid of that 2. I want to get rid of that 3. The first thing we're going to do is we're going to get rid of that 3. I'm going to make it a 0. Now, I can't just subtract 3, subtract 3, subtract 3. We're not allowed to do that. But I can take -3 times row 1, add that to row 2, and put it in for row 2. Go ahead and pause the video and try it and see what you get. You should have got, notice I'm writing row 1 in there because that didn't change. The only thing we're changing is row 2. -3 times 1 is -3, plus 3 is 0. -3 times -2 is 6. 6 minus 5 is 1. -3 times -2 is -6, and 9 is 3. So now, see what's happened here. What is this row telling me? That no x's and 1 y is 3. I've already got it solved for y. I'm going to do one more augmentation to get rid of that -2. Here's what I'm going to do. I'm going to take 2 times row 2, add that to row 1, and put it in for row 1. All right, again, hit pause on the video and see if you can do it. What you should have got was, now row 2 is not changing. 2 times nothing is nothing, plus 1 is 1. 2 times 1 is 2, plus a -2 is 0. 2 times 3 is 6, plus 2 is 8. So what the new row here is telling you is that x equals 8. And we have our solution, the point 8. Oops. Oh no, I had it right. I thought I had that backwards for a moment. X is 8, y is 3. There it is. There we go. There's the solution. So solving systems using augmented matrices. Okay, can be very frustrating, can be very difficult. In the homework, the first set of the homework is you're going to be rewriting from equations to matrices, augmented matrices. The second part, you're going to write from augmented matrices to equations. And then the third part, you're going to do just one step. It'll give you a matrix and ask you to do 1 or 2 steps to see what happens. And then the next part in the homework, they're going to give you some augmented matrices that are already solved, and you're going to have to write out what the solutions are. But where it starts to get hard is when we have to put all of this together. Start from scratch to write and then solve. We just did one example, but I picked an example that I knew was going to come out nice and kind of easy here. Let's do another one that maybe will be a little bit more interesting. Suppose I have the equation. This is number 40, by the way, out of the exercise set. X plus 2y equals 5, and x plus y equals 3. There's my system. Now, certainly there's a lot of much easier ways of solving this system than using augmented matrices. I could solve either of these for x easily, or I could just multiply by one of them by a negative to get the x's eliminate. Lots of different ways of solving this one. We're going to use augmented matrices. All right, here we go. First step, writing it as an augmented matrix. We're going to use coefficients 1, 2, with the augmentation of the constant of 5, 1, 1, 3. All right, so I want to make that a 0. I want to get that to be a 0. I want to make that go away. And I'm going to do it by using row operations where I can use row 1. I am going to do row 1 plus, or no, let's see, negative row 1 plus row 2, and put it in for row 2. The negative of that plus that. That'll give me the 0. All right, hit pause. Try it. The first row isn't changing. The second row, negative 1 plus 1 is 0. Negative 2 plus 1 is negative 1. Negative 5 plus 3 is negative 2. Now, not quite done, not quite what I wanted here. I want a positive 1 there. So now what I'm going to do is I'm going to take row 2 and divide it by a negative 1 and put it in for row 2. Basically, I'm just going to divide that whole equation, that whole row there, by a negative number to change it to make it positive. That's what I want. All right, so the first row isn't changing. 1, 2, and 5. 0 divided by negative 1 is still 0. Negative 1 divided by negative 1 is positive 1. Negative 2 divided by negative 1 is positive 2. Almost done. This has told me that no x's plus 1y is 2. In other words, y equals 2. Now I need to get rid of this 2. How am I going to do that? I'm going to take negative 2 times row 2 and add it to row 1 and put it in for row 1. By the way, how do you know what to do and when to do it? It all comes with practice. The more practice, it'll start coming to you. It'll start getting easier. All right, so I'm changing row 1. I'm not going to change row 2. Negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 2 is negative 4, plus 5 is 1. So that's told me that x equals 1 and y equals 2. 1x and no y's is 1. No x's and 1y is 2. My solution is to this system of equations is the point 1, 2. Now you're going to see these in 3x3s, so let's do an example of solving a 3x3 matrix. Well, these can get tough. These can get very confusing, very frustrating. You can spin out of control pretty quickly on these things. Let's take a look at a 3x3. I'm going to do problem number 50 out of the exercise set. It says 2x plus, well, no, number 50 is a weird one, equals negative 4, and then negative 2y plus 4z equals 0, and 3x minus 2z equals negative 11. Let me make sure I've copied that down right. 2x and y is negative 4, negative 2y and 4z is 0, 3x's minus 2z's is negative 11. And you might be looking at this and thinking, wait a minute, is this really a system of 3 equations with 3 variables? Yes, I've got x, y's, and z's. So when I translate this into my augmented matrix, the first column is going to be the coefficient of x's. I've got a 2. Notice there's no x's in this second equation. 0 and a 3. The second column is going to be the coefficients of y's. I've got a 1, a negative 2, and I've got no y's down there. The third column is going to be the coefficients of z's. I've got no z's there, 4, and negative 2. And then my constants, negative 4, 0, negative 11. All right, so with a system of 3 equations with 3 variables, we really want to do the same thing. I want to do all my row operations until all these numbers are gone. They're all zeros except for 1's down the main diagonal. 1x equals something. 1y equals something. 1z equals something. And I want to make all the other zeros. Well, I got a couple of zeros already. That's kind of nice. I got a 0 here, which is nice. Next thing I want to do is I want to get rid of that 3 right there. I want to make that 3. See if I can make that 3 a 0. How am I going to do that? All right. Well, I'm going to combine. That's not going to help me, is it? I'm going to need to do something here. If I did, let's see, negative 3 row 1's and added it to 2 row 3's and put it in for row 3. Negative 3 times that and 2 times that. I'm going to get a negative 6 and a positive 6. It'll give me a 0 in there in row 3. All right, try hitting pause and doing that first step and seeing what happens. I'm only changing row 3. Oh, let me make that a little bit bigger. I'm only changing row 3. So the first two rows, 2, 1, 0, negative 4, and 0, negative 2, 4, 0, they're not going to change. Negative 3 times 2 is negative 6. 2 times 3 is positive 6. Give me 0. Negative 3 times 1 is negative 3. 2 times 0 is 0. Negative 3 and 0 gives me negative 3. Negative 3 times nothing is nothing. 2 times negative 2 is negative 4. 3 times negative 4 is positive 12. 2 times negative 11 is negative 22. Negative 22 and positive 12 gives me negative 10. Wait, did I do that last one right? Negative 3 times negative 4, that's 12. And negative 22, 12 minus 22, negative 2. Okay, yeah, got it. Okay. All right. The next thing I want to do is I want to see if I can get rid of this negative 3 here. But I have to be careful. If I multiply everything in row 1 by 3 and add it, 3 times 1 is 3 and negative 3 is 0. That'll work. But watch what happens here. 3 times 2 is 6 plus 0. I get a 6 back here. I lose the 0 I've got right there. So I don't want to use row 1. I'm only going to use rows 2 and 3 to get rid of that negative 3. And what I'm going to do is I'm going to do negative 3 times row 2 and add it to 2 times row 3 and put it in for row 3. Negative 3 times negative 2 is positive 6, and negative 6 are going to give me that 0. Whoops, I fell off the screen. Sorry. I just noticed. All right, let me make sure everybody's caught up on me. All right, so go ahead and try this. Try that operation and see what you end up with. Hit pause on the video. Rows 1 and 2 aren't changing. All right, so let's see. Negative 3 times 0 is 0, and 2 times 0 is 0, so I still get 0 here. Negative 3 times negative 2 is 6. 2 times negative 3 is negative 6. 6 and negative 6, I get 0 there. Negative 3 times positive 4 is negative 12. 2 times negative 4 is negative 8. Negative 12 and negative 8 is negative 20. Negative 3 times 0 is 0. And 2 times negative 10 is negative 20. What now? I'm going to take row 3 and divide it by negative 20 and put it in for row 3. Basically, divide by negative 20, divide by negative 20, divide by negative 20, divide by negative 20. Pause the video, see if you can do that operation and what you end up with. Zero divided by negative 20, 0. 0 divided by negative 20, 0. Negative 20 divided by negative 20, 1. Negative 20 divided by negative 20, 1. And here we have our first part of our solution. No x's and no y's, and 1z equals 1. So now I want to work backwards. Keep going. Keep using these row operations. I'm going to get rid of that 4 by taking negative 4 times row 3, adding it to row 2 and putting it in for row 2. All right, go ahead and pause the video. Try this step. See what you get. I'm not changing rows 1 and 3. I'm only changing row 2. Negative 4 times 0 is 0, plus 0 is 0. Negative 4 times 0 is 0, plus negative 2 is negative 2. Negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times 1 is negative 4, plus 0 is negative 4. What's next? Row 2 divided by negative 2 and put it in for row 2. I'm going to divide everything by negative 2 to make that a nice, well-behaved positive 1. All right, again, hit pause on the video, try it, and see if you can get the resulting matrix. So I'm not changing row 1, and I'm not going to change row 3. 0 divided by negative 2, 0. Negative 2 divided by negative 2, 1. 0 divided by negative 2, 0. Negative 4 divided by negative 2, positive 2. So now I know I've still got that whole z is equal to 1, but now I also know that y is equal to 2. One more thing I need to do. I need to get rid of that 1 there. Well, actually, I need to get rid of that 1, and then I'm going to need to get rid of that 2. I'm going to get rid of that 1 first. What I'm going to do is I'm going to take row 1, and I'm going to subtract row 2 and put it in for row 1. So 2 minus 1, 1 minus 1, 0 minus 0, negative 4 minus 2. Go ahead and try this row. Hit pause on the video. Try the row operations. Hopefully you're not just sitting there watching me plow through these things. If you are, you're going to be completely lost. You really have to try these things. You have to do them. So I'm not changing rows 2 or row 3. All right, 2 minus 0, 2. 1 minus 1, 0. 0 minus 0, 0. Negative 4 minus 2, negative 6. All right, only one step left. Do you see it? Take that row 1 and divide everything by 2 and put it in for row 1. So I'm not going to change row 2. I'm not going to change row 1. 2 divided by 2, 1. 0 divided by 2, 0. 0 divided by 2, 0. Negative 6 divided by 2, negative 3. And here we have our solution. 1x, no y's and no z's. 1y and 1z. Or, another way of writing it, negative 3, 2, 1. The 3 by 3s are tough. There's a lot of work on the 3 by 3s. I think I only gave you 2 of the 3 by 3s to try in the homework. So what I'd like you to do now is I want you to do the homework. (12)(2). It starts on page 888. And I want you to do problems numbers 5, 7, 9, 11, 13, 15, 25, and 27, 37, and 43, 47, and then 51 and 61. A couple of different sets in there. This is the same assignment that's on the syllabus. So this is the same as in the syllabus. And of course, when you're done, email me the completed work. This one can be kind of frustrating. It's easy to spin out of control in this one. If you're kind of running out of control, or you get some horrible fraction answers, most of them should be relatively nice, well behaved. You might have a 1/2 or 3/2 or 2/3 here and there, but most of the answers should be relatively nice. The ones that you're going to have a hard time with are the 43, 47, 51, and 61. The other ones are all pretty straightforward. These last 4 ones, you actually have to put it all together in these last 4. This one's already in upper echelon form, so you're already done. But these last 4, those are the ones that are going to give you a hard time, guys. All right, good luck. Remember to show me the work. If you don't do the work, you won't get any credit. And I will talk to you again soon. Bye.